Okay, the Mayan number system. This number system actually was the first one to have a symbol for zero. So let's look at the digits. So here's what we have for zero: one dot for one, two dots for two, three dots represent three, four dots represent four. Well, one line represents five. So when you want to show six, then you use one line that represents five and one dot, six. Line two dots, seven. Line is five. Three dots, well, eight. And one line, four dots, actually represents nine. If you want to show 10, then you use two lines because each line is actually five. So two lines represent 10. 11, you use two lines and one dot. 12, two lines, two dots. 13, two lines, three dots. 14, two lines and four dots. Okay, 15, you can use three lines, right? Each line represents five. 16, three lines, one dot. Well, 17, three lines, two dots. 18, three lines, three dots, and 19. Okay, three lines and four dots, right? Okay, these are the digits in Mayan number system. Well, what about the place values? Okay, first place value is 1, just like before. Okay, then we have 20. Guys, after that, we expect to have 20 to the second power, right? But instead of 20 squared, we have 18 times 20. Many people believe that, we have 18 times 20 because Mayan people, they had 360 days in a year. Well, that is why after 20, instead of having 20 squared, we have 18 times 20. And then we have 18 times 20 squared, then 18 times 20 to the third power, and so on. So make sure that you know these place values. Okay, place values in Maya number system. Okay, here we go. So, well, how can I change a Maya numeral to a base 10 or Hindu Arabic numeral? Okay, first of all, the Maya numeral are written like that. Okay, guys, one important thing is that we move from the bottom to the top. Okay, first of all, I write down what each digit is. Okay, so look at the first one. We have three lines. Each line represents 5, right? So 3 lines is 15 plus 1 is 16. Look at the second one. You have one line, which is 5 plus 3 dots, that's 8. Well, here you go, the third one. That's a symbol for 0. And the last one, we have two lines. Each one represents 5. So 5 and 5, 10 plus 3 dots is 13, right? Now, we write down the place value of each digit. As I said, don't forget in Maya numeral, we move from the bottom to the top, okay? So the place value of first one, as you see, we write from the bottom to the top, is 1. Then we have 20. Then we have 18 times 20 because Mayan people, they had 360 days in a year. And then we have 18 times 20 squared. Then we multiply each digit by its place value. 16 times 1 is 16. 8 times 20, right? Well, then 0 times its place value, and 13 times 18 times 20 squared. Here are the results. 16 times 1 is 16. 8 times 20, 160. 0 times 360 is 0. And 13 times 18 times 20 squared is 93,600. Now add the results, add all these values. What we get is 93,776. So you change the Maya numeral to a Hindu Arabic or base 10 numeral, right? Okay, well, let me give you an example. Okay. let me see. Okay, sorry, let me get back. Here is the Mayan number system. Okay, let me find an example from your textbook. Okay, let's change this numeral, this one. Here's from your textbook. Change this numeral, this Mayan numeral, to Hindu Arabic numeral. Okay, so I give you around 1 minute. First of all, write down what each digit is. Write down the place value of each digit. Multiply multiply each digit by its place value and add the results. Don't forget to move from the bottom to the top. Go ahead. Okay, I'm gonna change this Maya numeral into Hindu Arabic or base 10. If you need more time, you can pause the video, okay? So, well, this digit, we have one line, one dot, so 5 plus 1 is actually 6. This digit is 0 and this one, okay, 3 lines, each one is 5, so it's 15. Plus 4 is 19. Now, I write down the place value of each digit. We move from the bottom to the top, right? So place value of first one is 1. Then we have 20. And then we have 18 times 20. Okay, 6 times 1 is 6. 0 times 20 is 0. And 19. Okay, 19 times 18 times 20 is 6,840. Is that right? So 19 times 18 times 20. So 6,840. So now add them all. 6,840 plus 0 plus 6, well, is 6,846. Here we go. We change that Maya numeral into Hindu Arabic or base 10. Here we go. So that's the example we solved before. Here we go. Now I want to talk about binary or base 2 number system. Well, we talk about base 2, when we were talking about logic, right? We said that in logic, when we have a statement, in logic, it's either true or false. We said that it's like, binary system that you have 0 and 1, okay? So binary or base 2 number system. The digits that are allowed in base 2 are 0 and 1. So we only have two digits in base 2 that are 0 and 1. You can make any numeral that we want using these two, 0 and 1. And the place values are powers of 2. Okay, we have 1, 2 to 1, 2 to 2, 2 to 3, 2 to 4. Here are the place values in base 2. Okay, well, when we have a numeral that doesn't have any subscript, well, our assumption is that it's in base 10, okay? Or, Hindu Arabic. For example, if I write like this, without any subscript, well, it's 10, so it's base 10 or Hindu Arabic, okay? So that is why if I'm talking about other bases, the bases that are not base 10, I have to write down what base I'm talking about. For example, if I'm talking about 1, 0 base 2, here we go. I have to write down base 2 or like that. Or like that, base 2. I need to mention, okay? Well, so let's say I have a numeral like this in base 2. How I read that is 1001 base 2. Guys, it's not 1001. 1001 means it's base 10, right? So you're talking about base 2. So that's how you read that. 1001 base 2. Okay? So the numeral is 1001 base 2. Okay. Well, if I have a numeral in base 2, how can I change that to a Hindu Arabic numeral or base 10? Well, just like before. First of all, write down the place values that are powers of 2. Okay. Then, write down the place value of each digit and multiply each digit by its place value and then add the result, just like before. For example, let's say I want to convert 1001 base 2 to base 10 or Hindu Arabic. Okay, first of all, I write down the place values. Here we go. Powers of 2. So 1001 base 2. Then I write down the place value of each digit. Don't forget to write down from right to left. So place value of this one is 1. Then we have 2 to 1. Then we have 2 to 2 and 2 to 3. Here we go. Multiply each digit by its place value. So digit is 1. The place value is 2 to the third power plus. The digit is 0. Its place value is 2 squared. The digit is 0, its place value is 2 to 1. The digit is 1, its place value is 1. And then add them all, right? So then the answer is 1 times 2 to 3 is 8, plus 0 times 4 is 0. 0 times 2 is 0. 1 times 1 is 1. So 8 plus 0 plus 0 plus 1 is 9. So 1001 base 2 is actually numeral 9 in base 10 or Hindu Arabic. Okay? Well, so what we do, we write down the place values. We multiply each digit by its place value. Don't forget to write down the place value of each digit. You write it down from right to left. Multiply each digit by its place value and then add the results. Here we go. Okay? So in any base, the digit symbols begin at 0 and they go up to 1 less than the base. For example, if you are talking about, base 7, the digits that are allowed, they start from 0, so that's base 7. Okay, they go up to 1 less than the base. Okay, 7 minus 1 is 6, so 0 to 6. So in base 7, the digits that are allowed are from 0 to 6. Base 5, the digits that are allowed are from 0 to 4. Base 2, the digits that are allowed 0 and 1. Base 10, as you see, from 0 to 9. Base 8 from 0 to 7, right? So base 2, the place values are powers of 2. Base 3, the place values are powers of 3. Base 4, the digits that are allowed are from 0 to 3, and the place values are powers of 4, right? Base 5, the place values are powers of 5, and the digits in base 5 are from 0 to 4. Okay, so if you're working in base B, the digits that are allowed are from 0 to B minus 1, right? And the place values in base B are powers of B, right? So I want you to look at this table, think about it, and I want to give you an example. Okay, well, the place values in base 2 are powers of 2. Okay, here are the place values. I want you to follow those steps to change, okay, 1 0 base 2 to a numeral in base 10. So 1 0 base 2. Change it to a numeral in base 10. Okay, go ahead. I'll give you around 1 minute. So write down the place value of each digit. Don't forget to write down from right to left and multiply each digit by its place value and add the results. See what you get. Okay, 1 0 base 2, the place values, are powers of 2 because we're working base 2. You want to change it to a numeral in base 10. So what I'm going to do, I'm going to write down the place value of each digit. I write it down from right to left, from right, okay? So the place value of this one is 1. The place value of this digit is 2 to 1. Now we multiply each digit by its place value. So the digit is 1, the place value 2 to 1 plus digit is 0, its place value is 1. So what do you get? 2 plus 0, which is 2, right? So multiply each digit by its place value, right? Add the results, so I get 2, right? So 1 0 base 2 is actually numeral 2 in base 10 or Hindu Arabic. Okay. What about 1 0 base 6? If I want to convert that, well, we are talking about base 6. So first of all, I write down the place values or powers of 6. 1, 61, 62, 63, 64, and so on. Then I have 1 0 base 6. Well, I write down the place value of each digit. I write down from right to left. So place value of this digit is 1. The place value of this digit is 61. Then I multiply each digit by its place value. Digit is 1. Its place value is 61 plus The digit is 0 times its place value, which is 1. And then I add 6 plus 0 is 6. So 1 0 base 6 is 6. I don't want you to memorize, but it's good to know that 1 0 base b is b. For example, 1 0 base 7 base 7 is 7. Or 1 0 base 8 is actually 8. 1 0 base b is b. Okay, you can just follow this instruction. Write it down the place values and multiply each digit by its place value, add the results, to convert from any base to base 10 or Hindu Arabic. Here we go. Well, convert 4726 base 8 to base 10 or Hindu Arabic. Okay. What I do, first of all, I write down the place values, okay? Base 8. The place values are powers of 8, right? 1, 8 to 1, 8 to 2, 8 to 3, 8 to 4, and so on. Then, write down the place value of each digit from right to left. So I have 4, 7, 2, 6, base 8. Okay, from right to left, place value of this one is 1. Place value of this digit is 8 to 1. Place value of this digit is 8 to 2. And the place value of this digit is 8 to 3. Then, multiply each digit by its place value and then add the results. Digit is 4 times its place value, which is 8 to 3. Add it to the next one. The digit is 7. Its place value is 8 squared. Add it to the next one. The digit is 2. The place value is 8 to 1. And then add it to the next one. The digit is 6 and the place value is 1. Okay, now add them all. So first of all, we write down the place values. We are working base 8. You want to change from base 8 to base 10. So the place values are powers of 8. Then we write down the place value of each digit. We multiply each digit by its place value, right? And then we add the results. When you add, you get 2,518. So 4726 base 8 is 2,518 in Hindu Arabic, or base 10. Now, I want you to convert 43 base 5 to base 10 and 2035 base 6 to base 10. And I give you around 2 minutes. If you need actually more time, okay, you can pause the video. Okay, I give you around 1-2 minutes, okay? 1 or 2 minutes. Go ahead. Don't forget to follow those instructions. First of all, write down the place values. Well, write the place value of each digit, multiply each digit by its place value, and then add the results. Okay, convert 43 base 5 to base 10. Okay, first of all, this one. It's base 5, so I'm going to write down the place values. Place values then are powers of 5. 1, 5 to 1, 5 to 2, 5 to 3, 5 to 4, so on. Then, well, is 4 3 base 5? I'm going to write down the place value of each digit from right to left. So place value of this digit is 1. Place value of this digit is 5 to 1. Then I multiply each digit by its place value and then add the result. So the digit is 4 times its place value 5 to 1. Add it to the next one. The digit is 3 and its place value is 1. Here we go. 4 times 5 is 20 plus 3 times 1, 3 is 23. So 4 3 base 5 is actually 23. I'm going to follow the same, strategy for 2035 base 6. Well, it's base 6. So first of all, I write down the place values. So powers of 6, 1, 61, 62, 63, 64, 65, so on, right? And I write down the place value of each digit. Okay, so it's 2035 base 6. Write down the place values from right to left. Okay, so the place value of 5 is 1, then this digit 61, this digit 62, this digit 63. Okay, now multiply each digit by its place value. Okay, the digit is 2 times its place value 6 cubed plus the digit is 0 times its place value 6 squared. The digit is 3, the place value is 61, and the digit is 5, its place value is 1. Well, add the results. Okay, so okay, let's see what we get. 6 to the power of 3, okay, is, okay, so it's 2 times 216. Is that right? So 6 times 6 times 6. Yes. So 0 times 6 squared is 0. 3 times 6 is 18. And 5 times 1 is 5. So 216 times 2 is 432 plus 0 plus 18 plus 5. So the answer is, let me add them all, plus 5. So it's 455. So 2035 base 6 is actually 455. Let's check our answers. So for 3 base 5, write down the place values, multiply each digit by its place value, so it's 23. I follow the same steps for 2035 base 6 to change it to a numeral in base 10. Write down the place values, multiply each digit by its place value, add the results to 455. Well, I'm gonna stop here and yeah. Well, we continue this topic with actually converting from, base 10 to other bases, and then we're gonna talk about how to add, subtract, multiply, or do divisions in other bases. Really cool, right?